Section 3.3 is about logarithmic functions. We usually just abbreviate that to the word log, but it is short for logarithm, okay? And what we're going to do is we're going to put together what we've done in the first two sections. In 3.1, we talked about inverse functions, and then in 3.2, we talked about exponential functions. Well, exponential functions come in two types. Here's what we have if we have exponential growth. That would be y equals b to the x, where the base b is bigger than 1. This would be exponential decay. That's y equals b to the x, but where the base is a positive number between 0 and 1. Notice, in both cases, the domain is all real numbers. It's just one interval from negative infinity to infinity. There are no gaps in it, okay? If I have exponential growth, my function is always increasing. If I have exponential decay, my function is always decreasing. If we have a function that's always increasing or always decreasing on an interval, it's got to be 1 to 1 on that interval. Because if I'm increasing here, once I hit a y value, I'm going to move past it. The rest of the time, I'm going to be above it. I'm not going to hit that y value again. And so we will pass the horizontal line test on both of these graphs. No horizontal line is going to intersect the graph more than once. So if I have y equals b to the x, in either case, whether it's exponential growth or exponential decay, this is 1 to 1, and therefore it's invertible. And so we're going to take a look in this section at what does the inverse look like. So let's suppose I have f of x equals, let's just go with 2 to the x. Let's take a specific example here where the base is 2. Since that's bigger than 1, that would be exponential growth in this case. Okay, so if I wanted to find the inverse, I would write y equals 2 to the x. That's the original function. To get to an equation that describes the inverse, I'm going to switch the roles of x and y. So I'm going to say x is 2 to the y. That equation right there describes the inverse. Now I know I want to take things a step further. I want to actually solve for this y. But I really want to point out this equation here, because usually when we're finding an inverse function, this right here, what we get when we just change x and y, is sort of an intermediate step. We do it, then we get the formula for the inverse function, and that's what we work with from that point on. This is almost always what I'm going to go to when I'm working with these log functions, which is going to be what we call the inverse function. Because now I want to solve for y. And I don't have a nice way of undoing that. I'm taking 2 to the yth power. A root isn't going to help. Okay? I could try to take the yth root of this, but then I'd get 2. I wouldn't get y. I need to solve for the exponent. Now, up until now, we haven't learned a mathematical way to do that. But I can, in a sentence, describe what y is. I can certainly say y is the exponent, because that's what it is. Y is the exponent. It's the exponent I need when 2 is the base to get x. Okay. That basically takes that equation, it rearranges it into an English sentence that tells me what y is. Now, we're just going to introduce some mathematical shorthand. It's going to say exactly this. It's just not going to take as long to write. So, y is y. Is, that's going to be equal. Okay. The exponent, that's going to be the log. Log means exponent. That is the key to understanding log functions. And again, log is short for the word logarithm. Okay. It's just a fancy word for exponent. Okay. So y is the exponent. Now I need to specify that 2 is the base. I'm going to do that with a subscript. Okay. So if this is the line that I'm writing on, the 2 is a little bit below that, okay? So it's the exponent I need when 2 is the base to get x. So I'm just going to put x right there on the same line as where I put log. Okay, that is the inverse for the exponential function with 2 as the base. The inverse for an exponential function with 2 as the base is a log function with 2 as the base. So now I could say f inverse of x, if I wanted to use my inverse function notation, is the log base 2 of x. Okay, excellent. Now, let's see if we can't evaluate that. Practice evaluating some log functions. Okay. So let's say I wanted to evaluate the log base 2 of 8. Okay. All right. What I find it helpful to do when I'm working with logs is I'm going to give that a name. Haven't used x in this problem, so I'm just going to call it x. And I want to now try to rewrite that using exponential notation. Because most people, myself included, are more comfortable working with exponential expressions than log expressions. Okay? So anytime I have an exponential expression, there are 3 things. There's a base, there's an exponent, and there's a result. Now, there's nothing sacred about these symbols. I put a square for the base, a circle for the exponent, and a triangle for the result. I just like to have different shapes, and I'll try to always be consistent. So it's square to the circle equals the triangle. So I can talk about where I'm going to put things, because I'm basically going to be rearranging these things. I've got a 2, an 8, and an x, 3 things to go in 3 places, and this just allows me to talk about where I'm putting them. Okay. So this says the exponent I need when 2 is the base. 2 is the base. Let's put 2 in the square, because that was where we put the base. Okay. The exponent I need when 2 is the base to get 8. 8 is the result. Okay. And then if I'm saying the log is x, I'm saying the exponent is x. So x goes in that exponent position. Now when I rewrite it this way, I can see what that should be. 2 to what power would give me 8? I'm familiar with my powers of 2. X is going to be 3. Okay. So the log base 2 of 8 is equal to 3. Excellent. Let's try the log base 2 of 1/4. Again, I like to give it a name so that I've got 3 things, and I'm just going to rearrange them to write them in exponential form. So this says the exponent I need when 2 is the base. To get 1/4, that's the result. The log is x, the exponent is x. Okay. Now, 2 to what power is going to give me 1/4? Okay. Well, it might help to actually rewrite this a little bit. 1/4, I know that's 1 over 2 squared. Okay. I don't have to work with the whole fraction. I can just look at the denominator and say that denominator, that's a power of 2. That's 2 squared. But because it's in the denominator, that means that's 2 to the negative 2. And so then I can see that exponent there is going to be negative 2. So in evaluating log functions, I'm almost always going to be rewriting things in this exponential form. Really important that you understand log means exponent. So when we're working with log functions, we're going to be working with exponential functions, just sort of rearranged a little bit. All right,